board. So can you see my PowerPoint? Okay, perfect. So again, it's an overview, okay? It's not a... So first, network foundation. What is a network? Okay, is a set of technology that connects computer or any other device. In our case, is any other device. Okay, allow communication, collaboration between users. Okay, network is anything that can provide connectivity. Okay, for example, the Wi-Fi, the technological Monterey Wi-Fi, it's a network. The 5G network that you have in your to use the smartphone outside the campus is a network. The Wi-Fi network that you have in your home is a network. Okay, network is the technology that connect device or to connect people. How a network works? It is there are other ways to network works, but today it's the main approach. Okay. Before I continue, I show one video that I use in network course. Give me a second. That I believe is good to, and after I publish in the Canvas, okay? Networking. Oh. Give me a second, guys. I can share to share my audio. Okay. Okay. This video is about it's an old video, okay? It's a very, very old video. I watched this video, I believe, I don't know, maybe in 2000, maybe before, I cannot remember. But this video is very nice because it's a move, like a cartoon, that explains how the network, how a network works, okay? Pay attention, I believe you can, if you don't have any skill about network, this video is amazing. If you already have skills about networking, this video, I believe, improve your understanding using a picture representation, okay? Okay, I will start.
Por primera vez en la historia, la gente y las máquinas están trabajando juntos cumpliendo un sueño. Una unión de fuerzas que no conoce límites geográficos ni repara en raza, creencia o color. Una nueva era donde la comunicación verdaderamente lleva a unir a la gente. Esto es el amanecer en la red. ¿Quieren conocer cómo funciona? Haga clic aquí. para comenzar su viaje hacia la red. ¿Sabe lo que pasa exactamente cuando hace clic en ese link? Usted inicia un flujo de información dentro del computador. Esta información viaja hacia su local propio de mensajería personal, donde un protocolo de comunicaciones, el señor IP, lo empaqueta, etiqueta y pone en camino. Cada paquete es limitado en su tamaño. El local de mensajería debe decidir cómo dividir la información y cómo empaquetarla. Cada paquete necesita una etiqueta describiendo información importante, tales como la dirección del remitente, del destinatario y el tipo de paquete que es. Debido a que este paquete en particular va dirigido a Internet, también recibe una etiqueta para el servidor proxy, el cual tiene una función especial como veremos más tarde. En este punto los datos abandonan nuestra máquina y salen hacia la red cableada de nuestra corporación. El paquete es lanzado hacia la red de área local, o LAN. Esta red es usada para conectar a todas las computadoras locales, impresoras, etc. La LAN es un lugar nada controlado y desafortunadamente pueden ocurrir accidentes. La carretera de la LAN está repleta con toda clase de información. Hay paquetes IP, paquetes Nobel, paquetes Appletop. Ahí va contra el tráfico como siempre. El router local lee las direcciones y si es necesario pone los paquetes en otra red. El router, símbolo de control en un mundo desordenado sin par. Así es él, sistemático, desinteresado, metódico, conservador, y en algunas veces no precisamente rápido, pero exacto, casi siempre. Cuando los paquetes dejan el ruteador, siguen su camino a través de la intranet o red corporativa. Adelante hacia el switch ruteador. Un poco más eficiente que el router, el switch router trabaja rápido y suelta los paquetes enrutándolos hábilmente por su camino, como una máquina de pinball digital si lo prefiere. Cuando los paquetes llegan a su destino, son recolectados por la interfaz de red para ser enviados al siguiente nivel. En este caso, el proxy. El proxy es usado por muchas empresas como un intermediario, con la función de establecer y compartir entre varios usuarios una única conexión de Internet y también por razones de seguridad. Como puede verse, todos los paquetes son de diferentes tamaños, dependiendo de su contenido. El proxy abre el paquete y busca la dirección web o URL. Dependiendo si la dirección es admisible, el paquete se enviará hacia Internet. Existen, sin embargo, algunas direcciones que no cuentan con la aprobación del proxy, según cómo haya sido configurado, de acuerdo a las políticas corporativas o de administración. Tales direcciones son inmediatamente ejecutadas. Este no es nuestro caso. Luego, nuestro paquete vuelve nuevamente a la ruta dentro de nuestra LAN. Próximo paso, el firewall. El firewall corporativo o local sirve a dos propósitos. Previene intromisiones más bien indeseables provenientes desde Internet y evita que información delicada de nuestro computador o de la empresa sea enviada hacia Internet. Una vez que pasa el firewall, un router recoge cada paquete y lo coloca en un camino o ancho de banda, como es llamado, mucho más estrecho. Obviamente el camino no es lo suficientemente amplio para llevar todos los paquetes. Ahora, tal vez se pregunte, ¿qué pasa con todos esos paquetes que no logran recorrer todo el camino? Bien, cuando el señor IP no obtiene un recibo de que el paquete fue recibido a su tiempo debido, simplemente envía un paquete de reemplazo. Ahora estamos listos para entrar al mundo de Internet, una telaraña de redes interconectadas, la cual se extiende por todo el orbe. Routers y switch establecen enlaces entre las redes. La red es un ambiente completamente distinto de lo que podemos encontrar dentro de las paredes de nuestra red local o LAN. Allá afuera es el salvaje oeste. Abundante espacio, abundantes oportunidades. Las nuevas ideas encuentran suelo fértil que empuja el desarrollo de sus posibilidades. A causa de esta libertad, algunos peligros también pueden acechar. Nunca podemos saber cuándo encontraremos al terrible ping de la muerte, una versión especial del paquete ping normal de interrogación entre máquinas, con la que algún idiota intenta desquiciar servidores o incluso a nuestro propio PC. Las rutas o caminos que los paquetes pueden tomar son satélites, líneas telefónicas o incluso cables transoceánicos. No siempre toman el camino más corto, pero de cualquier modo llegarán allá. Tal vez es por eso que algunas veces es irónicamente llamada World Wide Web. Pero cuando todo trabaja sin problemas, podemos circunnavegar el orbe 5 veces en unos cuantos milisegundos. Y todo al costo de una llamada local o menos. Cerca del fin de nuestro viaje y encontrando el computador servidor en donde está la página web solicitada, encontraremos otro firewall. Dependiendo de nuestra perspectiva, el firewall puede ser un resguardo de seguridad o un terrible adversario, dependiendo de qué lado estemos y cuáles sean nuestras intenciones. El firewall está diseñado para dejar entrar solamente aquellos paquetes que cumplen con el criterio de selección. Este firewall tiene abiertos los puertos 80 y 25, que son literales puertas de entrada. Todo intento en los demás puertos será cancelado. El puerto 25 es usado para paquetes de correo, mientras que el puerto 80 es la entrada de los paquetes de Internet hacia el servidor web. Dentro del firewall, los paquetes son filtrados más concienzudamente. Algunos paquetes pasan fácilmente por la aduana y otros se ven más bien dudosos. El oficial del firewall no es fácilmente engañado, como en el caso de este paquete ping de la muerte, que trata de hacerse pasar un paquete ping normal. Para aquellos paquetes lo suficientemente afortunados o sanitos como para llegar hasta aquí, su jornada casi ha terminado. Están dirigidos hacia la interfaz para ser llevados hasta el servidor web. Actualmente un servidor web puede correr sobre diversas cosas, desde un mainframe, una webcam, hasta el computador de escritorio. ¿O por qué no en nuestro refrigerador? Con la configuración apropiada podríamos encontrar si hay los ingredientes para hacer pollo con salsa o si tiene que ir de compras. Recuerde, este es el amanecer de la red. Casi todo es posible. Uno por uno, los paquetes son recibidos, abiertos y desempacados. La información que contienen, esto es, nuestra solicitud de información, es enviada hacia la aplicación del servidor web. El paquete en sí es reciclado, listo para ser usado otra vez y llenado con la información solicitada. Etiquetado y enviado de regreso hacia nosotros. Regresa por el firewall del servidor web, router y a través de todo Internet. De vuelta a nuestro firewall corporativo y hasta nuestra interfaz en nuestro computador. Aquí es suministrado el navegador de Internet con la información solicitada, como por ejemplo esta película. Todo esto ocurre cada vez que usted busca o solicita una dirección en Internet. Nuestros confiados paquetes se dirigen felices hacia el ocaso de otro día más, sabiendo que han cumplido la voluntad de su amo, satisfechos con sus esfuerzos y confiando en un mundo mejor. ¿No es este un final feliz?
Okay. What did you think about this slide? This video, sorry.
Al final no entendí qué es lo que es el lag.
¿Cómo? Perdón.
¿Y lo de la pérdida de paquetes?
Sí, sí.
¿Llega a ocurrir? Pero realmente, ¿qué es el lag?
Sí. Okay. This video just. I like this video because it uses a very simplest term to show how the things happen. Okay, things that it is picture here. Okay, things that you have a computer that send message to a target system recipient. What happens? Things that you need to send this emoji here. The emoji is broken in a small piece, and each part of this small piece flow through your computer to another computer using a different path. Okay, you don't need to use the same path, but multiple paths. The name of the unit that you use to broke. Okay, for example, you broke this emoji in a small piece. The piece, the name is a packet. Okay. Okay. A packet is a small part of the information that you transfer to another place. Okay. And in the time, in the destination, what happens? You need to reassemble this package in information that you send. It's the generic approach of the network. Okay. LTE uses this approach, 5G uses this approach. In the past, it's a little different, but now all the networks, independent the technology that you use package to transmit your data to one place to another. Okay. In the video that you saw, okay, that you watched, you see the same approach. We use in more details, showing some problems. I like this video because I believe now it's simplified to understand what you want to explain in network. Okay. One important concept in the network is the protocol. Okay, to understand protocol, think about the two people talking. For example, in our case, I'm a Brazilian, speak Portuguese. You are Spanish, you are Mexican that speak Spanish. Okay. If I talk, for example, Portuguese to you and you speak Spanish to me, a lot of information is lost. It's the reason that you define the English protocol, the English language, to talk, because in the English language, both sides can understand what you want to talk to other. Okay. A protocol is like that. For example, when you define to use think, for example, your smartphone. Your smartphone talks Wi-Fi, but you use a server that is not you have Wi-Fi, but you have, for example, a cable. You need a protocol that translates the message one place to other. Okay, a protocol is a set of rules that define how a message is translated to one place to other. It's like, again, it's like the English in our case. A protocol defines what do you want to do, the application, where are you going, the address, how do you get there, the media types, for example, Wi-Fi, cabling, optical cabling, and others. And did you get there? Acknowledge how to check the errors and other things. Okay, did you understand what is a protocol? Can you give me an example of the protocol in the real life? It's not required to be an example of the networking. Any other example? Guys?
Writing el abecedario.
Yes. Yes. For example, when you enter in the school, okay, in the tech, you have a set of rules that you need to follow. Okay, these rules is a protocol. Okay, a language is a protocol. Okay, and the network, for example, when you use 5G or use when you define the 5G, you define how to address the device, how to secure the device, how the message is routing one place to other, how the message is transported one place to other. Everything that when you define, I use 5G, is a set of rules that define the communication behavior in all details, in all aspect of the communication behavior. Okay, so you have different type of the protocols and different type of network. I try to explain here. The first type of network is the personal area network. Can you give me an example of the personal area network? I define a personal area network is a network of personal things. For example, the network that connects my smartphone with my watch, for example, is a personal area network. Who can provide me an example of a personal area network that you use every day?
Bluetooth.
Yes, Bluetooth, exactly. Bluetooth is an example of a personal area network that you use every day. There are others, for example, Zigbee. Zigbee is another technology that you use a personal area network. Okay, go ahead, Ricardo. Are you asking something?
Estoy recordando. Sí.
Gracias. I didn't start the record. Thank you. Oh, no, I recorded. Yes. Go ahead, Ricardo. Sorry. Any question, guys?
Oh, no.
Okay. Another type of networking is the, okay, about the personal area network. If you think a little about it, the personal area network is not a network that you need to transport a lot of data. It's a small data because it's the network that you use to connect things. For example, my smartphone can make a call, but use my smartwatch can make a call, and my smartwatch use the smartphone network. Okay, use the smartphone like a gateway to access, for example, the 4G or 5G. Another type of network is a local area network. A local area network is a little bigger network that connect things in a small place, but it's not to connect your things, but to connect device in a place. For example, in my office, I have a local area network installed. In your home, you have a local area network installed. Okay? Can you give me an example of a local area network? That you use every day?
In some games, you can connect to the local area network to play multiplayer, like in Minecraft or in Mario Kart, I think.
Yes, yes, sure. And which protocol, which technology do you use to connect these things? You have in your home? Wi-Fi, no?
Wi-Fi? Yeah.
Yes, Wi-Fi. Yes, Wi-Fi is a technology that you can use to connect a device in a local area network. You have another, okay? But the Wi-Fi is one good example. A metropolitan, before. Another example of local area network that you connect every day. Who can provide me? Well, which network you connect every day? That's a local area network. The Wi-Fi from tech, no? The Wi-Fi that we use in the school, in the campus, is a local area network. Okay? A metropolitan area network is a network that connects cities, okay, or that connect a big campus. The topology of the tech is not like that, okay? But things that you have a network that connect the campus from Mexico City with the campus with Santa Fe. It's the same network, okay? A network like that is a network that connects different builds in a city, is a metropolitan area network, okay? You can use Wi-Fi, it's not so good, but you can use, depend the distance. But most of the time you can use, for example, WiMAX. WiMAX is a technology, wireless technology. It's not exactly the Wi-Fi, but it's close to Wi-Fi, okay? There are a lot of similarities with the Wi-Fi, okay? WiMAX, then it's the name of the technology, WiMAX, okay? And one example, again, is not the case of the tech, but think that you have a network that connects directly the campus Santa Fe and the campus Mexico City. If this network exists, the name is Metropolitan Area Network. For example, the network that connects all the government agents inside the city is a metropolitan area network. Okay, it's a network that connects different places in a city. Okay. Finally, you have the wide area network. Okay, the one. This network connects far places one to other. Who can give me an example of the wide area network that you use every day?
Google?
No, Google is a service. A network that you use every day.
The World Wide Web?
Yes, the World Wide Web, the internet. The internet is a good example of a one. Okay, a lot of companies, including the tech, has, for example, you have a network that connects different campus. Okay, for example, the campus Mexico City with the campus, for example, in Monterrey, if the campus if Guadalajara and others. The network that connects this campus, different campus, is a wide area network. Is a one. Okay. The difference, for example, not about this one. The personal area network is a little different, okay? But the other network, the local area and the one, the difference is, for example, here you have a big bandwidth, okay? You have big bandwidth. I will talk about bandwidth in the next slide. And you have the cost of the bandwidth is very cheap. Okay. In the one you have a low bandwidth. Okay. But the cost is very expensive. For example, you can use satellites. Okay. You can use satellites. That is very expensive. And the satellites, the bandwidth is very smaller. It's very small. Okay. And in the metropolitan area is in the middle of the one and the LAN. Did you understand?
Yes.
Yes or no? Okay.
Yes.
Okay, we talk about the bandwidth. What is the bandwidth? The bandwidth is the capacity of the medium. For example, think that it's the cable, okay? It's a metallic cable that you have in the phone, okay? And think that this cable, you can transport data, okay? The bandwidth is okay. The bandwidth is the amount of data that you can transport one place to other, okay? Like publisher to subscriber, okay? The bandwidth is the amount of data that you can transport the one place to another, okay? And it's a very important concept because depending on the bandwidth that you have, you can enable or disable the possibility to use a specific application. There are, related to the bandwidth, you have the latency, okay? The latency is the amount of time, including delays, for the data transport to the other place. I believe a lot of you already use it, for example, the command ping in the Windows to check if one server or the one website is up or not. For example, when you ping, you use the command ping, like, for example, I will show you. So. Okay, when you use, for example, ping www tech mx, okay, you see what I'm doing here. I check if this site is available. Okay, when I use this command, I try to check if this site is available. But not only it, I check the delay. How many times I use to go and back, okay? For example, when I use the ping, okay, I'm here in Brazil, okay? And I ping the tech in Mexico, okay? In Mexico, okay? When a second, guys. When I send the ping command, I send the command ping, I go to the tech, receive the answer, and when I start the ping, I use the time 0, and the time final is when the package go and back. When it happens, I calculate the delta is equal TF minus T0, okay? This delta here is what you have here, okay? Did you understand?
Yes.
Yes.
Okay. Back to the presentation. Oh, teacher. So back here, the latency is the amount of time, including delay, for the data travel from one given point to another. Okay? When I type in, I go to the server and back. It's like the example that I showed in the when I type in to here, to Brazil, to the Mexico. Okay? Any questions?
What does ping mean?
Ping is a command. It's a command, okay? Is now I say it's a command that you have. Oh, sorry, guys. It's a command that you have in Windows. It's a command like you have. I don't know. Cop. It's a command of the operation system that you use to do these tests. Did you understand?
Yeah.
Okay. Another important concept is the jitter. Okay. A jitter is a little different. Remember that you have the delay. Okay. You have the delay. This latency can change in the time. To understand it, go back to this slide here. Okay. Did you see that the package can go to multiple paths? And you can have a problem here in one path to other, okay? A jitter is the variation of the delay. Remember, delay is the amount of time include delays. The latency is the amount of time that the package go to one place to other. Remember that you don't send only one command, you send multiple commands on multiple packages. The jitter is the variation of the delay. Okay, things, for example, you send the packet 1, 2, 3. Did you see that some packages is change the speed that's coming to the server? Did you see here? Pay attention here. Okay, 1, 2, or change. And when it change, you lost some information. Okay. The jitter is an important property to check, for example, in the voice. For example, one example here. Did you see here? You send the package in a specific free speed, but here in this point, oh, sorry, in this point, the package increase the delay between one package to other, okay? The jitter is very important, for example, to video application and to voice application. I believe you already see, for example, a video in Netflix or in the Amazon Prime, and sometimes the video stop to work, freezing. And after some few seconds, it continue or to jump to another part of the video. It's very common, for example, in live transmission, like a live transmission, like our course. Okay, for example, you have a lot of people watching a show, and sometimes the show freezing and go when the next time that you see is a little ahead. It's very common today to when you watch, for example, soccer games, games. You watch, you see the game, the players play soccer, and sometimes freeze the video and you see a little advance a few times ahead. Okay, did you understand what is it there?
Yes, but which are the causes of jitter or the main causes?
The main causes is, okay, oops. The main causes is the characteristics of the package network. Is the current network, for example, the RIP network has. Remember that you, if you see here in this picture, you need to broken the information in a small piece. And you cannot assure that the piece follow the same path. For example, one part of the piece go for this path, another one to this path, another one to this path. For example, when you transmit, you have some knowledge about the best path to send the package. However, during the transmission, for example, this router go down, and you need to send the package to another place, to another path, or go down, you need to retransmit part of the information. Or, for example, this router here is okay, but a few seconds late, receive a lot of package and it's busy, okay? When it's busy, it spend more time to reply the information to another place. It's some reasons that you have that cause the jitter. It's not again it's a problem that happens because the characteristics of the package network. How to solve this problem? To solve this problem is not the focus of this course, but you can use the QoS approach. What is QoS approach? Okay, when you, for example, when you start when you broken the information, inside each package, you set a flag like, oh, this package is very important, cannot suffer any jitter in delay, okay? When the router receives this package, he prioritizes this package in opposite to the others, okay? And you cannot mark all the package. You need to mark, for example, the video and the stream and the voice package. Okay. For example, when the router receives a video package and a web page package, the video package go ahead and pass first. And you pass all the videos first after you pass the reply or re-forward the other type of package. Did you understand?
Yeah, thank you.
Okay. So, okay. I give a break now, okay? And we return in 10 minutes. We return in 4, okay? See you soon,
Okay.
guys.